Hello and welcome to my MVP Day online session, which is entitled Automate Your Patching. My name is Sarah Lean and I'm a Cloud Solution Architect at Microsoft. I've been with Microsoft now for a year, and in my role within the Customer Success Unit, I speak to customers about data center transformations and how they can begin that journey into the cloud. When I'm not doing all of that though, you'll find me blogging and speaking at events like this or at user groups or conferences. You'll also find me in the winter months on the ice as I like to curl, and recently I've started taking up photography at night, taking the night skies and trying to get some astrophotography under my belt. If you want to get in contact with me via social media, my Twitter handle is @techieLass, and my blog is also linked there below. It's techieLass.com. So please do reach out to me. I'm happy to answer any questions or happy to make new connections with you. In my previous roles, I spent many a night and many a weekend inside data centers working away, trying to apply patches to servers, waiting for them to reboot, panicking when they didn't reboot, trying to work towards that 100% patch compliance and troubleshooting why we couldn't get the patches to apply or why something didn't work. So it quickly became one of my specialties to help build out our customers' patch schedules, group machines together and how they all interact with each other and understand their startup and shutdown procedures, understand which patches could be done during the day, which ones were only available at night for rebooting, how applying patches or reboots affected the applications. And I learned very quickly how to architect and actually build out WSUS infrastructures and laterally use System Center for patching as well. So patching is something I'm extremely passionate about. And I'm also extremely passionate about saving other IT professionals from having to spend their nights and weekends in the office in data centers applying these patches. It's not fun, and we shouldn't always have to be doing this. We should be using automation techniques where possible in order to save our IT professionals from having to give up their nights and weekends where possible. So today I'm going to introduce you to Azure Update Management. So during today's session, I'm going to give you an overview of Update Management as a service. I will walk you through the interface. I will show you how to onboard machines, both Azure machines and non-Azure machines. I'll take you through how the scheduling and deployment mechanisms work within Update Management. I'll show you how to review the results and manage that going forward. And we'll talk a bit about the pricing and how that works as well. So Azure Update Management is part of the Azure Automation toolset. So you'll find it embedded within Azure Automation. And what it helps you do is manage your operating system updates for Windows and Linux machines. As I previously mentioned, it supports machines in Azure and it also supports machines on-premise and where the machines live in other cloud providers. So it's fairly flexible and fairly agile as well. It can work as a standalone solution, so you can use it entirely separate, or you can use it to integrate with your System Center or your WSUS implementations already. Again, it's fairly flexible and agile for what you need it to be. So let's have a quick look at the Update Management interface and I'll walk you through some of the features within it. So as I mentioned before, the Update Management solution is actually part of Azure Automation. So in order to access it, we have to click into Automation Accounts. So if we click on All Services and search for Automation, and click on Automation Accounts. I've got several automation accounts within my subscriptions, but the one we're going to concentrate on is a lab one that I have set up for my home lab and some of my Azure VMs. So if we click into that, we'll see various different blades down the left-hand side here, but what we're concentrating on is the Update Management one. So this is the view that we have of my Update Management solution. And as you can see, I've got several servers connected, a lot of non-Azure ones, some Windows ones and some Linux ones. Because my lab hasn't been on for a wee while, a lot of them aren't compliant at the moment. So it's just working through trying to do that. But as you can see, we can get a quick overview of whether they're compliant, non-compliant, what patches are missing and how many patches are missing. So under missing updates, we can see all the various different updates that are missing as well and try and evaluate them. Under the Update Deployments tab, we will actually see the jobs that are running or have failed. Again, in this case, I've had my lab off for quite a while, so a lot of the jobs have failed because it hasn't been contactable. But you can see when the jobs do work, we get some success, and we get the maintenance window about how long they're actually running and the jobs have been running for. And the last tab is the scheduled update deployment. So these are the schedules that I have in place around when I want my machines to be patched and for how long the maintenance window I have. Up the top, you'll also get some buttons here. If you want to click on Add an Azure VM, you click on in here and you'd be able to onboard them. The Add non-Azure machines actually takes you through to the documentation describing what you need to do. Later in this session, we'll actually be onboarding VMs, both in Azure and non-Azure machines. So in terms of onboarding machines, we first have to look at what is supported and what is not supported. So at present, Windows Server 2008 and Windows Server 2008 R2 RTM is only supported in doing assessments. You can't actually apply updates using Azure Update Management. You can only assess what needs to be patched on the machines. So if you have the older operating systems like that, or even older 2003, 2000 machines, they are not supported. Going forward, anything that is older than Windows Server 2008 R2 SP1 is fully supported. There is a caveat that nano servers aren't supported. So again, if you're running some of those in your environment, you need to have a strategy for them. Update management only supports server technologies at the moment. It doesn't support client technology. So things like Windows 7 or Windows 10 are not supported either. In the last four columns of my table, we've got the Linux operating systems that are supported. So you've got CentOS 6 and 7, you've got Red Hat Enterprise 6 and 7, SUSE Linux Enterprise Server 11 and 12, and Ubuntu 14.04, 16.04 and 18.04 are all supported as well. So again, it's key to watching out for these things and be aware of them when you're implementing the strategy. Now we've had a look at the update management interface and we've looked at what clients are supported. Let's try and onboard some. So let's have a look at onboarding Azure machines first of all. To onboard an Azure machine, it's fairly simple. It's quite an easy process to go through. So within our update management blade, we'll click on Add Azure Machines. And the portal will load the ones that we have available within our subscriptions, and we can change this. So here we have a VM called Lab VM01, and it's ready to enable. So all we need to do is actually click on Enable. And what this will do is actually install the extension and point that extension on that Azure VM to our update management and use the automation account that we have. And if we click into the deployment and process, we'll be able to see that happening. Again, this can take anywhere between 30 minutes and 6 hours to actually appear in the portal. I found the Azure machines quite quick, to be honest, so once this is complete, you should have something within the portal to actually view. And we can see here the automation controls kind of deploying that, and it's linking our virtual machine with our Azure automation account and the update management solution as well. It's worth mentioning at this point how the agent actually works and how often it actually does a scan. So after a computer completes a scan for update compliance, the agent forwards that information in bulk to the Azure Log Analytics space. On a Windows computer, the compliance scan is run every 12 hours by default. In addition to the scan schedule, if you restart the MMA agent, the scan is initiated after 15 minutes. And on a Linux machine, the compliance scan is performed every 3 hours by default. And again, if the MMA agent on the Linux box is restarted, the compliance scan is initiated within 15 minutes of that agent restart. So please have some patience with this solution when you're implementing it. It can take a wee while for things to appear, and I know in previous experience it's been quite hard for me to sit there and wait for it to happen, but you can actually cause more damage if you don't wait. So please do bear with it as it goes along and does its processes in the background. So now that we've learned how to onboard machines that are within Azure, what do we do for the machines that aren't within Azure? The ones that live on premise or the ones that live in another cloud? We can still onboard them, and in order to do that, we have to download an agent and install that agent. Now, to get a hold of that agent, what we do is we go into the Azure portal and we go into Log Analytics. And we select the workspace, the Log Analytics workspace that we want to onboard these machines into. I'm going to click on my default workspace one. And if I click on Advanced Settings, I will be taken to the download page. Now, under Windows servers, you'll see there's several different options. There's a Windows agent for 64-bit machines, or there's a Windows agent for 32-bit machines. If we click on the Linux servers ones, we get the download agent for Linux. Now, download the relevant agent for the servers that you need, whether that be Linux or Windows. So I want to demonstrate how you onboard a Linux server. Onboarding a Windows server is fairly straightforward. You download the executable and you walk through a wizard and input some data. It's a straightforward install that anybody could walk through. But what I want to show you is the Linux one. So in here, the download agent for Linux takes you through to the documentation page, which is hosted on GitHub. And it gives you some information about the latest releases, bug fixes, versions, the SHA hash, the MD5 hash as well. So there's a lot of information here, but if you click on the OMS agent for Linux header, you're taken through to the install guides and full feedback on how to install it, how to troubleshoot it, etc. So here you get the quick install guide, and it's a one-line command, and you basically have to copy and paste this. You have to input your own OMS workspace ID and OMS workspace primary key, which you would get under your advanced settings. So it's your ID here and your primary key here. What I've done is already constructed this install script into 2 lines of code. I prefer to split it up and do it as two. So the first one would download the agent and it downloads the latest version available. And then the second part of the script actually installs it. So I've switched over to my Linux box and here's my putty session. So if I take my code, which I've already done, so this first part of the code downloads the latest agent from the internet. As you can see, it connects to the GitHub repository and downloads the agent. The second part of the code helps to onboard it and install it with my into my log analytics space. So after a few minutes, the agent is now installed. You can see the different processes that it's went through, and now that the OMS agent is onboarded. It may take anywhere between 30 minutes and 6 hours for it to appear within your log analytics or your update management console, so please be patient. You can actually do more damage if you try to troubleshoot it in that period. So patience is the key to implementing update management and installing agents. So please bear with it. As I say, it can be quite quick and I've seen it take a few minutes. Other times it can take a few hours. So bear with it. But that's the agent installed and that's us onboarded the machine into Azure. And we can now use update management to patch this machine even though it lives outside of Azure. So now that we've got our machines onboarded, let's look at what we need to do in order to schedule and deploy these updates to the machines. In order to get patches on machines, we have to create an update deployment. Under the Scheduled Update Deployment tab, we can see that I've already got 2 jobs scheduled. So I have one that will run at 3 p.m. today on one machine, and it will run weekly with a maintenance window of 120 minutes, and it'll look to install the Windows operating system patches on that machine. And I'll also have one called Linux VMs. Now that's scheduled to run tomorrow at 9:15 and that will run daily on 2 machines and again has a maintenance window of 180 minutes. Now, if we look back at this view, we'll see that some of my Windows machines are not compliant. So we need to create an update deployment for them. In order to do that, we click on Schedule Update Deployment on the top here. We give this update deployment a name, so we'll call it Windows VMs. As we're trying to patch Windows, we'll leave this tab selected as Windows. Um, there are multiple options in terms of how you deploy the patches. You can use groups. So if you have a large amount of machines, you can actually look at using the Azure groups, which will automatically, once a machine is added into that group, apply this patch update. In this case, as I don't have that many servers, I'm going to pick which machines I want to do. We have the option to import groups, again from another external system, or we can click on machines. And this should give us a list of the machines that it can see. I'm going to click on my Windows server, I'm going to click on my lab VM, I'm going to click on legacy server and the data server, and click OK. Next box I need to fill in is the update classifications. You get a whole load of different ones that you can apply. I'm quite happy to apply all of them, but again, please have a look at what these are and what they do differently. Depending on what your systems are and how your applications are, you may only want to roll out your critical updates and security updates and then manually look at update roll-ups, service packs, etc. I'm quite happy, as I say, to roll out all the updates that update management finds, so we'll leave that as is. You can exclude or include updates. So again, depending on your environmental needs, if you have an application that doesn't support a certain update, you can stop that from being deployed. Or if you have to have a certain update deployed, you can do it here as well. So in order to schedule this, I'm going to schedule a recurring one that happens every day, and I'm going to schedule it for later on today. So we'll say 10:30 today. I don't want it to expire. I want it to continue on and keep my environment up to date. You do have the option to run some pre and post scripts, so you can look at starting and stopping services on your VMs or starting and stopping machines on your Hyper-V hosts, etc. There are a whole bunch of script templates and scripts out there on the Marketplace gallery as well if you want to have a look at that. For my maintenance window, I'm going to give it 2 hours, so 120 minutes, so as that update management has that time to schedule and install the updates. And I'm always going to say reboot. Again, suit this down to your environmental needs. If you want to do the install of the patches automatically, but then reboot your machines manually, that's absolutely fine. Just schedule that as appropriate. Pick the solutions that are best within your environment, and we'll click create. And we should see this now within scheduled update deployments. Yep, it's provisioning and setting up that schedule to happen for our 4 machines. So what I'll do is I'll let that job get provisioned, I'll let it get scheduled, and I'll join you guys back once the patches have been applied. So here we are back in the update deployment schedule, and you can see that my Windows job that I scheduled is running, and it has been running for the last 16 odd minutes, and it's currently in progress. So if we drop into this, we can see that it's trying to patch these 4 machines and it's trying to apply these 3 updates, and it's saying in progress at the moment. And as that goes along, that job goes along, we'll get more information. There is logs here, and it can give you can drill into these, and it kind of gives you information about what it's doing. Again, there'll be more information as the job progresses and as the job finishes, and you'll be able to drill into that further through, and you'll be able to see errors or outputs that happen for troubleshooting. So now that my job has completed, my update management console is looking a bit more healthier. But I have a non-compliant machine here. There's a patch was missed from here. So if we go into update deployments, we'll see on our Windows job it's marking it as failed. So if we click into it, we can see a better progress update, and we can see that 3 of the machines were happily patched and succeeded, but 1 of them failed. So if we click onto the legacy server, we can drill down, and we've got this big red exception message up here, and if we look through it, we actually see the system has tried to shut down. So while the patches were applying, the server was rebooted. So that's a fairly obvious one. We'll just need to go back in, and the next time it should catch it. Again, this can happen if you're patching during the day. People can accidentally shut down a machine, or it doesn't actually come back up in time due to another patch, etc. So There is the information there in order to have a look at it and figure out what it is. Here, this has just been a case of it was reboot when the patches were trying to be applied, so it failed and the job exited. Um, so there is the ability to have a look at what's happening and understand why a patch hasn't been applied, and how you can try to troubleshoot it from there. You can also see things like the maintenance window here wasn't long enough. So if we drill into this one, it's saying the maintenance window was too small. So Update Management has calculated the amount of patches that had to be applied to that machine wasn't actually going to happen in the maintenance window that we'd specified. So again, you can either leave that to catch up on the next patching schedule, or you can schedule another update deployment to happen as a one-off to bring this machine up to scratch and make the maintenance window bigger. Or you could go and manually apply the patches, or just leave them. So it's entirely up to you. The information is there. Update Management's given you that feedback in order to understand it. So use the feedback, investigate it, and build your patching schedule up from there. The first time you schedule something, it may not be successful. You may get a lot of failures, you may get a lot of error messages, but again, just use the information that it's feeding you back and build that back into your patch schedule, and automate it and make it a lot better for each time and each iteration that you get to. So now that we understand how the product works and how we can use it, I just wanted to take a minute to have a look at the pricing. This is taken from the official documentation page, and you can see that Update Management is actually a free service in terms of using it. The only thing you will pay for is the log data that's stored within the log analytics service. So in terms of the log analytics space, you can see from this pricing detail as well that the first 5 gigs per month is generally free, and then onwards going from that, you're looking at probably £1.71, that's UK pounds, per gig per month. So again, it's not a costly service, and a data retention isn't costly either, but it's something to be aware of, especially when you're looking at strategies for your IT organisation. So the official documentation can be found on the first link. There is also a user voice website where you can suggest features, or you can vote on other suggestions from other users. And the product groups generally take note of this and look to implement these features where possible. So now that we've had a look at the interface, we understand what the product does. We've onboarded some of our machines, both Azure and non-Azure, and we've scheduled some deployment and had a look at what that looks like. I wanted to talk about best practices for a few minutes. And throughout my career, I've spent a lot of time trying to refine this process and understand how to make it better. And I would always say plan your patching, and that seems like a bit of an obvious step, but a lot of people forget to do it and do it on the back of, a matchbook. It's not possible to do it that way. I tended to get a big Excel spreadsheet and use lots of color coding and different methodology around that. And I found that was most useful. It gave people a visual idea of how we were doing it and kept us all right on the way that things were linked. So when you're doing that plan, try and group machines together. So if you have a web app and a SQL database backend, keep them together and patch them together so that they're in sync and you understand where the processes are. If you have machines that have multiple front ends and are load balanced, patch them on different days, patch them on different nights, but try and patch them quickly together. Don't leave one getting patched 1 week and then another for 3 or 4 weeks down the line. You're going to end up with disparity, and if you have issues, it's going to be harder to troubleshoot. So try and patch them one after the other in different nights. And automate as much as possible. Try and schedule things so that they are happening without human interaction where possible. It's not always possible with some applications, as you need to do some manual steps to in order to bring them down or bring them back up. But again, look at automating as much as possible, especially in your dev and test environments. Try and take that load off your teams as much as possible. Schedule reboots as much as possible. As we saw, Update Management has the ability to send that that reboot command when it's patching. So if you can reboot a server and not notice the downtime, or you can schedule the downtime during the day, again, dev test environments, please do. It kind of takes that load and that extra burden off your team. So schedule things as well as much as possible during the day. Do the reboots, do the patching during the day. That means that if there is something goes wrong, you have a full complement of your staff there. You're not relying on one person who's standing in a dark data center or sitting in a darkened room in their office, trying to troubleshoot themselves and trying to reach out to colleagues and wake people up in the middle of the night. If you schedule it during the day where possible, then if something does go wrong, you've got that full complement of your team behind you and you can troubleshoot it as quickly as possible and as easily as possible as well. So that's my learnings from the years that I've spent patching machines. So go out there, try and use update management and try and take some of these best practices on board as well. And lastly, thank you guys for taking the time to listen into my session. Hopefully you found it useful. If you've got any questions or you'd like to reach out to me about anything specific around Azure or data migrations, please do reach out to me. That's my Twitter handle there. It's @TechieLass, and I'll be happy to interact with you. But thank you again, and I'll hopefully get a chance to speak to you again in the future.